Hello everyone, let's watch the problem, and that is the problem D in Codeforces round 1004. And that is an interactive problem. You will be given an array x1 to xn, and there is a fixed but a hidden array y1 to yn. And both of these integers from 1 to n. The elements of array Y are unknown to us, and there is a very important conditions for all I, xi not equals to yi, and for all pairs xi, yi are distinct. So we know if xi equals to xj, and we will know yi not equals to yj because of this condition, right? And there are two objects, and the first object is that if there is a directed graph with n vertex, and with an edge of the form xi to yi. And the second object is that there are n points on a coordinate plane, and the ith point has coordinates xi, yi. Mm, uh, the problem lets us to guess which object is uh, uh, in this problem. We need to guess which object and the jury has thought, and we need to query the jury twice, and in every query we need to specify two numbers I and j, and we will receive one number. If the jury select the object A, we will receive the links of the shortest path from vertex I to vertex j in the graph, or 0 if there is no path. If the jury has thought of the second object, we will receive the Manhattan distance between the points I and j, that is xi minus xj plus yi minus yj. So we only can ask twice queries to determine which of the objects the jury has thought of. So I think that is this condition is the most important. So if we query A and B, and the response, if the response equals to 0, which means the object must be the first object. That is because we don't have any two pairs are equals, right? Because all pairs are distinct. So the Manhattan distance between any 2 points must be bigger than 0. So if the response is equals to 0, the answer must be A. That is very important. So we need to think how to find a very useful queries. In this case, we can see actually for me to think this problem in the beginning, I want to find, I guess, maybe I should ask two numbers that has the minimum numbers and the maximum numbers. I think that may be a very useful strategy to find the answer. And after thinking, and we can we can see in this case, uh, 223. In this case, we can find we don't have 1, right? So, which means if that is the object 1, we don't have any adage from 1 to another numbers. So, if we ask 1 to another numbers, we know in the second object the response never can be 0, right? So if we ask 1 to another numbers, if the response is bigger than 0, the answer must be B. Or the response equals to 0, which means that is must be a graph, and we don't have the adage from 1 to another numbers, so the response must can be 0. So the answer is A. So that is a very useful strategy for this case. If we miss some numbers, we can use this strategy to find the answers. However, if we miss this case, any numbers occurs once, so we need to find another strategy to get the answer. In the beginning, I think maybe we need to ask the the response between the maximum number and the minimum number. Actually, I don't know why, but I think maybe that will become very useful. As I know that if that is a graph, for example, we have 5 numbers, and the minimum distance between any two numbers must be less than 4, right? If that is a sorry. In this case, the distance between 1 to 5 is the distance between 1 to 5 is 4, and we can draw any adage from 5 to any other numbers. I don't care that. The distance from 1 to 5 is 4. So if we find the minimum number, the response between the minimum number and the maximum numbers, the response between the minimum number and the maximum numbers, if the response equals to bigger than n minus 1, the answer must be B. That is makes sense, right? That is because if that is the first object and it is a graph, and the answer must not become not must not greater than n minus 1. The biggest minimum distance is n minus 1. So if the response bigger than n minus 1, the answer must be the second object. And if the response less than n minus 1, the answer must be object A. That is because if we ask the minimum number between the response between the minimum number and the maximum number, if the answer is the second object, the answer must not less than n minus 1. That is because 5 minus 1 already has 4. So that is cannot less than n minus 1. So if the answer is less than n minus 1, the answer must be object A. So if the answer equals to n minus 1, we can see how we deal with this case. We need to do another query. We can see if we ask the 1 to 5 and the distance the response is n minus 1, we need to care about the adage from 5 to we don't know which number it will go, right? For example, it will go to it maybe go to number 2 or maybe go to number 1. If we ask another query from 5 to 1, if the answer is object A, we can see if the adage from 5 to any numbers that's not equals to 1, the answer must be 0. Or if the adage from 5 to 1, the answer can be 1, right? If the answers is object B, and we ask the 5 to 1, this answer also can bigger than n minus 1, bigger or equals to n minus 1, and so we can only ask the 5 and 1 again. The first query is ask 1 to 5, and the second query is ask 5 and 1, and we can know the answer eventually. So that is my code. In the beginning, we can get all the A, and we can use if else. If the size not equals to n, which means there are some numbers occurs more than once, and some numbers don't occur. So we can find which numbers don't occur, and we just can find any other numbers in any other number, and we ask this query and get the response. If the response equals to 0, which means that is a graph, and there is no added from I to any other numbers, so we can just output A. Else, if the response not equals to 0, which means that is not impossible to that is not impossible. That is impossible. The object A is impossible because we don't have any added from I to any other numbers. So we just output the number the object B, and in this case we can solve that very easily. Else, if all the numbers occurs once, we can find the index I, that's AI equals to 1, and the index j, that's aj equals to n, and we can ask this query if the response bigger than n minus 1, which means the answer must be object B. That is because if the answer is object A, the response never greater than n minus 1, right? So if the response less than n minus 1, the response the answer must be object A, because about the object B, the response never less than n minus 1, because n and I has contribute n minus 1. So in the second dimension, we if the second dimension is equal, the last answer also become n minus 1. So it cannot less than n minus 1. Else we can ask another query j and I. If the response equals to 0 or 1, 0 means the addition from phi to any other numbers not equals to 1, and if the response is 1, that means the addition is from phi to 1. So we can output A, else output B. Yeah, that is the code.